So today I'll be doing chapter 15, number 67 in our physics notebook. It states the 15-gram head of a bobblehead doll oscillates in a simple harmonic motion at a frequency of 4 hertz. So I just wrote down what we know, which is the mass and the frequency. So the first question asks, what is the spring constant of the spring on which the head is mounted? So I just used these two equations that we know, which is the frequency, which is equals 1 divided by the period, and the period equals 2 pi times square root mass divided by the spring constant. So I'm just gonna, I just plugged in the time, the period into here. And then it gives me this, and I'm essentially just solving for k. So once I do my algebra, k equals to the mass times 2 pi frequency squared. And when I plug in everything we know, so I just converted the grams to kilograms, and I plugged in the 4 hertz. So you're left with 9.465 newtons per meter. So that is the spring constant. Okay. Now the second part asks, the amplitude of the head's oscillations decrease to 0.5 centimeters in 4 seconds. What is the head's damping constant? So for the damping constant, I will be using this equation, which is amplitude in terms of time equals to the initial amplitude e to negative b t divided by 2m, which is mass, time, and this is the damping constant. So I'm gonna solve for b. So just show you guys my algebra. Alright, so once I solve for b, this is what I'm left with, which is negative 2 times the mass divided by the time, ln the amplitude in terms of time divided by the initial amplitude. So I plugged everything in. Once again, converted grams to kilograms. So this is what they gave us in terms of the mass. And then the time is 4 seconds. And then once again, it does say the oscillations decrease to 0.5 centimeters in 4 seconds. So that's where this comes from. And then this is amplitude in terms of time. And once again, it says oscillation decreases to 0.5 centimeters in 4 seconds. So this is the amplitude they're giving us in terms of time. Okay, and it's divided by the initial amplitude, which is 2 centimeters. So this is the only problem I had with this problem, was getting the initial amplitude. With the information given, which is the mass, the frequency, and now we solved for the spring constant, there wasn't anything that allowed me to get the initial amplitude. I tried everything and I couldn't get it. So I did check physics night book, the solutions manual, and in the solutions manual it simply had the 2 centimeters. So I'm assuming that they just it was a mistake and it was a piece of information they were supposed to give us and they just did not. So yeah, so this is where the 2 come from. So I did get this from the solution manual. And once again, like, if there was some way to solve this, it would have shown in the solution manual, but it did not. And I myself did try. So that's where that 2 centimeters come from, if you're confused. And yeah. So once I plug everything in, I get that the damping constant is 0.010 kilograms per second. So our spring constant is about 9.5 newtons per meter, and our damping constant is 0.01 kilograms per second.